What is up, everyone? Welcome to a new episode of our Forever Store, and I think today is a good day to start our storage and to see what we can do there. I think we have a good portion of our peer-to-peer lib. Then we're going to make the storage, then we're going to make a server, implement that storage into the server, and then we can do some shenanigans. Let me see. What do we have? Main. I think we're going to make a new file. We're going to call this storage go, I think. Or store. Doesn't really matter. Package main. I'm going to say type storage. Or store. Maybe store. Maybe store is good. It's going to be a structure. And then let me quickly find a good spot here. And do we need something? Maybe store options or something. Type store opts. There's gonna be a struct also. And we're gonna have some stuff. I'm gonna keep this here for now. Let's do. What's going on with this cursor? Store test. What is this? I'm gonna do the first function. So if you want to write to disk, right? So basically what we're going to do is some kind of a content addressable storage where we can save anything in a deep nested folder based on the transformation of the key. You will see. So I'm going to say something like func as store write stream, because I'm going to stream it, or try at least. We're going to say key is going to be a string, and then we're going to say an R IO reader, right? What's going on here? A reader like this. We're going to return an error. Yes, let's save it real quick. And then, so something like this, right? So the path name, we could do it. Maybe this. The path name is going to be some kind of a transformation of the key, right? So we could say something like transform func, or maybe path transform func, which is going to be a type of a path transform func, right? And I'm going to say it's going to be a function. We're going to say of the string of the key, and it will return a string. It's easy as that. And then you could say the store ops that the path transform func is going to be a path transform func, right? Needs to be that signature. Yes, and then we could say here that the store opts, we could just embed it. And then we could say a func new store. I'm going to give this opts, which are store opts. And we're going to return a pointer to a store, maybe an error, not quite sure. And we're going to return a pointer to the store. And then we're going to say that the store opts are going to be the opts, right? Something like that. Of course, if you make a test file, I'm going to make the store test actually. Store test go, right? And I'm going to rename this real quick to store. Yes. Let's close this and let's make another file. What's going on here? Let's open up store on this side, and of course test on this side. We're going to say package main func test store t. It's going to be testing t, and then I'm going to say, for example, that the S is going to be a new store. We need options, and options is going to be store options. Yeah, and the transform func. Let's make a default one for now. Default path transform func is going to be a func of key string to a string, and we're gonna return. Actually, let's make it clean. What's going on? Let's make it clean. We're gonna say return the key. Very simple thing. That's gonna be a var. Yeah. And you could say default path transform func, which is all good. And we're gonna say the opts here. And then we have a store. What's going on here? All right. Yes, so we have this path name. And then we could say something like s path transform func this key. Right? And then we have a path name. Let's return null. Let's bring it up higher. And then we're going to say something like the file and the error is going to be OS. Actually, we need to make if r is going to be OS mkdir, and I think we need to do all, especially for our content addressable shenanigans. We're going to mkdir all the key, no, the path name. Like this, we're going to say if r is not null. We're going to return the errors. What does mkdir all do? A file name. I think it's, I'm not quite sure with this file name, these file permissions. We will figure that out. I think it's mode perm. Not quite sure. So we're gonna make all the folders we are needed, and you will see why. And then we're gonna say. Then we need a file name actually. And the file name for now is gonna be the key. We can't. Let's say it's some file name. We don't care for now. We're gonna fix this because we're gonna use some tricks. We're gonna make a hash of the contents, right? We're gonna make a hash, and that's gonna be the file name inside of that path name folder. That's pretty neat. You will see. Thought about this last night. Then we're gonna actually say here fr is gonna be os open. We're gonna open the file. I think it's the path name plus slash the file name, like this. And we're gonna say if there is an error, we're gonna return the errors. Then we have a file, and then we're gonna say if, I think it's n, and r is gonna be io. Copy for streaming copy, right? Because io copy, let me quickly, I will show you. We're gonna stream this, right? We're gonna not, you will see. io copy, we're gonna say copy the file with the reader, and if there is an error, we're gonna say return the r. Maybe we should do an fmt or maybe a log print f. I'm gonna say written %d bytes to disk, like this, and that should be good. Mate, we could do something like this, right? We're gonna say path and file name is gonna be the path name plus it's gonna be this thing that we did, and then the file name, right? And then we could say path and file name. That's not true, this one. Path and file name. Did I make a mistake? Path and what's OS open actually? Just the name, right? Oh yeah. Let's see what's going on here. Like this. We could do something like percentage %s. And maybe do the pattern file name. All right. Yes. Let's test this real quick. So we're going to say, and now we're going to make our transform func and make it beautiful. So we have this S is going to be a new store opts. Yes. And then we're going to say, let's say we want to store something, right? Let's say we want to store as write stream. Let's make a key. Let's say it's going to be my special picture, right? Could be a special picture, and I'm going to say this needs to be a reader, right? Let's say data is going to be bytes new reader, and we're going to say bytes some JPEG bytes, right? It doesn't matter. It's bytes, but right? So we're going to say it's going to be some JPEG, right? And then we're going to say data. And then we're going to say if r. Actually, we should use testify, to be honest, but hey. We're going to say t error. And then the r like this. And then, yeah, I think that's good enough to test. Can I do make test real quick? No such file or directory. Or what are we making? Do we need to make create file? Maybe we need to do os create. That could also be a case, eh? Make test. Yes. So you can see written 14 bytes to disk, and this is our location, right? My special picture, some file name. Let's open up B. Let's open up. You see, it's my special picture, the folder, and then we have our file name, right? Which is good. Let's keep it there. Of course, we're also gonna do a configuration where we can set the root of the file system and blah 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 blah. Yada yada yada. Right. So, all right. So let's make a nice transform function. We're gonna test this real quick here. We're gonna say func test path transform func. I'm gonna say t testing t. And we're gonna make this. Let's make it at the top. I know we're gonna split things out as usual, right? We're gonna make things beautiful as later on. Let's make it. How can I call this? Let's make it cas. Cas control addressable path transform func. And we're gonna take in a key, which is a string. We're gonna return a string. All right. And this is the magic. You will see this is gonna be so cool. So we're gonna say func. All right. So we're gonna take a SHA-1 or an MD5. It doesn't matter. I'm gonna take a SHA-1 because we will have more bytes. We're gonna have a longer thing. Because I think MD5, let me open up MD5. MD5, sum. Yeah. What's MD5 size? We don't know. I think it's 20 or 16. I don't know. I forgot. So guess control addressable path transform func. How are we gonna do this? First of all, let's hash this thing. So we're gonna say that the hash is gonna be SHA-1 sum of the key, right? Can we not do this? We need to have bytes, right? Bytes of the key. Then we have a hash. Then we're going to say that the hash string is going to be hex, because now we have bytes, right? You're going to say hex and encode to string, and it's going to be the hash, right? What's going on? Oh, this will, what does it return hash? I think hash returns a 20 byte. And of course, encode to string takes a slice, so we can convert this to slice by doing this. A very neat trick, by the way, guys. If you want to convert a fixed, let's say you have a 20 byte, right? And you want to convert this to a slice, then you need to do this, right? Easy trick. Because a lot of people are still using these loops to convert it to a slice, which is okay, but it's unnecessary, right? It's unnecessary performance waste of CPU. So we have this hash string, and then we're going to say something like the block size, and that's going to be, so we have 20, right? Let's say a pad block size. Let's say a block size of 5. And I'm going to say that the slice length, and that's going to be, I have no clue. I think it's len, the hash string, divided by the block size. And then we're going to say that the paths, wait, now I need to think. This is gonna be on the top of my head. It's not Bats is gonna be, is it slice length? Yeah. It's this. It's slice length. Yeah. So paths. Wait. So we could do. Yeah. Paths is gonna be make me a slice of bytes, I guess, or even a slice of string actually. And we're gonna say the slice len. I'm gonna pre-make it. Oh yeah, and then we're gonna say for, and we're gonna loop through len paths, I guess, or even you could say slice len. It doesn't really matter. Slice len is actually it's already a number, right? So what am I doing here? Like this. Then we're gonna say from to is gonna be it's gonna be I times block size. I times block size plus block size. And then we're going to say we're going to say paths y equals the hash string. Look at this, the hash string from to. Right? And then we're gonna, then we have this path. And then we could say return strings join. Man, this is actually insane. Strings join. Strings join. The paths. Can we do this? Actually, we can't, because we can. Strings joins paths. And then we're gonna join it with the slash, right, for the path thingy. Yes. Woohoo. Let's try this. We're gonna say that the path name from our key, right? So we're gonna, let's say we have a key, right? We're gonna store, for example, a byte. It's gonna be a string actually. So we're gonna say mom's best pictures, mom best picture, right? And the path name of that thing is gonna be. So we're gonna each key is going to be transformed to a certain path on disk. Mom's best picture, and the path name is going to be cas path transform func. We're going to give that key, And then we're gonna basically, I don't know what it's gonna be, so let's print it out. fmt print ln the path name. Let us run this. You see? This is our path name. Right? So we're gonna make a folder, this folder, then inside this folder we're gonna make this folder, and inside this folder this. So we're gonna go in depth, right? So we're gonna have a nice depth of folders for everything. And yeah, so we can store these things on disk that way. And we can change this up, right? It could be that we only have 2 depth or 3 depth or whatever. But now we have a 5 depth, which is good. Nice. The question is, how are we going to test this? Actually, what we could do is run this again. I have no clue, man. I'm going to just copy this. And I'm going to say if path name. It's not the best thing to do, but hey, if path name is not this, then we're going to say t error. We could say actually expected path name. We're going to say something like this. Let's yoink it and paste it in here. Expected path name, and we're going to say type an error f t have this, want this path name, expected path name. And we don't need to do this t, by the way. All right. Something like that. Something like that. All right, so we're going to say that the path name is going to be transform func. So we could do, it's not going to be the default transform func. We're going to say it's the gas path transform func. And you can make your own transform funcs, and we can extend it with whatever you wanna do. You could do a git type thing. It doesn't matter, right? All right, so the next thing we need to do is this file name. This file name is not okay. We want to have an MD5 hash or something, or even a SHA hash. It doesn't really matter. It needs to be hashed. So, and of course, things are going to be encrypted, I know, but for now. I think the problem is we have this reader, right? This reader. So what we could do, enable to hash the contents of the reader, the bytes of the reader, right? We need to read. But we also need to read to copy it to the file, right? We have the file, we have our reader, and we need to copy the reader into the file, which will read. And once the reader has been read, it's done. So enable to do that, I think you're going to first read into a buffer. So we're going to say buffer is going to be a new bytes buffer, right? It's very interesting actually, because we do a lot of these networking stuff, and now we are doing these file reading shenanigans, which is nice, right? And then we're going to say, I'm going to say IO copy, and we're going to copy this reader into a buffer. And then we're going to say something like that, the file name itself, the file name bytes is going to be MD5, the sum of the buff bytes, like this. Then we're going to say that the file name is going to be a hex encode to string of the file name bytes. Then we can do this path and file name thingy. Then we're going to create it. And of course, this reader is already we can do anything with it. So we're going to say, can we do buff? That would be nice. That would be nice. Is it going to work? Yes. Look at this. So now we're going to see, right? Let's open up our folder. So we're going to say this one, and inside this folder we have this structure, this structure, this structure, 1, 2, 3, 4, 5, 6, 7. Why do we have so much? Yeah, it's normally. It's because, yeah. Is it? Yeah, so we have these nested folders, right? I think it's okay. Let me... It's the, and then this one. This one, this one, this one. And then we have this file, which is .jpeg. So we are storing this on disk already. It's nice, nice. Look at these folders. I like it, I like it. And if we want to read, it's the same principle. We know exactly. We transform the key we want to read, and it will be... Wait, we have a trouble. We cannot transform it like that. Because how do we read something? If we read it, we need to... No, we can't. We made a mistake. Let's close this up. We cannot do this, file name bytes. I think... that's not true. Because right now we are storing. Let's make... I think we need... You know where I'm going, right? Because if we want to read the key and we have our key, we don't know what's inside most of the time. So if we want to have the full path, we need to have the bytes of the thing we want to read, the content of the data, so we can hash it to know its file name. But that's impossible, right? To get something. So I have an idea. We're gonna say something like a type, a path key. Gonna be a struct, and a path key is gonna hold the path name, which is gonna be a string, but also the original. Is that the thing? Original key, maybe. Original is good. So this path transform func could return a path key. Right, we're gonna return a path key, and then we're gonna say that the we could say return me a path key. And the path key is gonna have the path name, and the path name is gonna be strings. I'm just gonna type it out again. Strings join this thing that we did, right? We're gonna say paths, and then we're gonna join it with this, and then we're gonna say that the original is gonna be the hash string, right? Like this. Expected path name, and I'm gonna say expected path, expected original key, and that's gonna be the path key, but without these things, right? I'm making so no, man, I cannot type original. So then we're gonna say path key here. Then we're gonna say the path key. Path name is gonna be this, right? And then we could actually copy this again, paste it. Then I'm gonna say path key original should be the expected path name. It's gonna be path name original. What's going on with the original key? No, it's gonna be expected original key. Yes. This is gonna work. Yeah, of course we have some issues, I understand. So we're gonna say that the path key, can I make this like this or this? I don't care. And then we're gonna say make everything is gonna be the path key, path name, path name. Wait, we don't need this. We don't need to copy this. Actually, we can. I think we. Path and file name is going to be the path key, this, and then we're going to say. Actually, what we could do. Look at this. Let's do it like this. I don't know what I'm doing actually. Path name. Yeah. Of course, we have some issues in our test. Like this, and then we're gonna say what's going on here. What's going on? Oh, it's the. Yeah, it's true. What's going on? Unknown field path name. And then we can make a function, right? We can say func. We could say p path key, and let's say file name. Yes, file name is going to return a string, and we could just return like this. We could say return, and we can make it clean. We could say fmt sprint s, and we could say it's going to be %s slash %s, and that's it. And then we're going to say p path name, p original, s print. What's going on? F. Yes, that's the file name. So we're gonna make the path name, the path and file name. Only thing we need. Actually, we could do it. That's going to be path key, file name, right? And instead of copying this buff, we can copy the error, right? I think that's gonna be something. There's gonna be something. I think we are at a good track. Let's test the storage. Yes, so we are written to disk, this whole shebang. Right, so now you can see that we make these folders, right? And the file name is going to be the path name, but then laid out. So then we can find it, right? Then we can retrieve it, right? So let's test this real quick. Yeah. I think I'm going to leave it for this video, and I will record right after. So these videos are going to be 30 minutes, 35 minutes, which is easier for me to upload and all that stuff, right? So I'll see you in the next video right away.